If that restoring torque comes directly proportional to again minus of angular displacement, then it means it is going to be SHM. Or from the torque, we can calculate the angular acceleration alpha. Because formula of the torque का tau is equal to I alpha, where I is the moment of inertia, rotation analogous of mass. So it will be torque by I, that becomes minus K by I into theta. Alpha is minus omega square theta. Correct? So in this case is that we have to find the omega, and from omega we get the time period as 2 pi by omega. So like simple SHM क्या था हमने, like the normal simple pendulum. But simple pendulum can be assumed as an angular SHM also. Simple pendulum के लिए we can apply both the approach like f is equal to minus kx, or we can also assume this to be like an angular SHM in terms of angle theta. Forces acting will be mg. जब ये mean position पे था, when it was vertical, it has no torque because both of the forces are passing through the axis. It does not have any force. Torque is zero. That is the mean position. Give a displacement and then calculate the torque due to it. Torque acting on this ball, on this bob, will be force mg into perpendicular distance, which is L sin theta, and it is opposite to the displacement. हमने anti-clockwise displace किया और mg का torque है clockwise. Torque is force into perpendicular distance. If this theta is large, then it will be oscillatory periodic, but not SHM. Only for small angle, we can approximate theta sin theta to be theta. When angle is less than 10 degree or so, and it is measured in radian, sin theta को हम theta के equal लिख सकते हैं. Sin 30 degree is not 30 degree, but sin pi by 6 is equal to pi by 6. So अभी आ गया tau is equal to I alpha. Alpha is proportional to theta. So a general relation जो आएगा, that is minus mgl by I into theta. This is for any shape of pendulum, not just a simple pendulum. Any type of physical pendulum, whether it is a rod or it is a disc, anything start oscillating like a pendulum, then we can directly apply this formula. सिंपल पेंडुलम के लिए हमने लास्ट क्लास में किया था फोर्स के तरीके से T is equal to 2 pi root L by G. When G will change, then time period will change. Accordingly, the formula will become 2 pi root L by G effective. Here, I is the moment of inertia about that axis of rotation. और वो जो भी body है, if it is a particle, then it will be just ml square. If it is a rod, then about one end of the rod is ml square by 3. And likewise, for any shape, we can find its moment of inertia by applying the parallel axis theorem. Moment of inertia about the axis of rotation, which is passing through point O in this diagram. And L, जिसको हम यहाँ पे थोड़ा और better कर लेते हैं, in terms of any physical pendulum, we represent it by R. R is the distance because L is also not here the total length. L plus radius, क्योंकि जहाँ पर ये mg act करता है, that is the center of the sphere. So we calculate the distance from point of suspension to the center of gravity. Point of suspension to the center of gravity. So that's why it becomes R sin theta. And in this formula, R is the distance between axis or point O, distance between point O and center of gravity where mg is acting. Center of gravity of whatever body it is there. If it is a sphere center, if it is a rod, it will be rod center, etc. Right? So जैसे फॉर्मूले से कंपेयर कर लोगे तो अल्फा आ गया माइनस ओमेगा स्क्वायर थीटा. ओमेगा will become root of mgr by I. Somehow you understood what is this? It's actually the mid of the chapter, so a little background is required. Simple harmonic motion. Force is proportional to minus times displacement. But now this is the analogous version in the rotational part or angular motion. Soumya?
Yeah, sir, I got it.
Okay, so just like we write equation for linear SHM as x equals to a sin omega t plus phi. Similarly, the angular SHM theta will be theta naught sin omega t plus phi. where theta naught is the maximum angular displacement. So 2 pi root I by mgr, that's the formula for time period of this physical pendulum. 2 pi under root of I divided by mgr. Any physical pendulum, any shape of pendulum, we can find the we can find the time period by applying this formula. Whether it was a particle, it is a rod, it is a disk. So let's say instead of this simple pendulum, there is a rod of mass m and length L, which itself is oscillating about one end, x is passing through one end. It is given an angular displacement of theta, and then it starts performing SHM. Harsh,
Yes, sir.
moment of
Hello.
inertia of rod about an axis passing through one end. रॉड का मोमेंट ऑफ इनर्शिया उसके एंड के अबाउट, रॉड का मोमेंट ऑफ इनर्शिया उसके एंड से पास वाले एक्सिस के अबाउट क्या होता है?
2 ml²/3. अच्छा, जी सर.
ml स्क्वायर बाई 3. सेंटर के अबाउट होता है ml स्क्वायर बाई 12 divided by mg. Center of gravity is exactly at the midpoint. So the distance from point of suspension to the center of gravity is L by 2, L by 2. So in one single step, m gone, L gone, you get 2 pi under root 2L by 3g. This is the time period of oscillation of this rod. Understood?
Yes,
Okay.
sir.
Find the time period of oscillation of. Find the time period of oscillation of disk. Suppose there is a disk of mass m, radius r. Find the time period of SHM of this. This is a disk of mass m. You have to apply that formula directly. No need to derive or something. P is equal to 2 pi root I upon mgr. I about this axis, so you have to be careful. Rushil, okay, Rushil is here. Yeah.
Yes, sir.
What will be the time period for this disk?
2 pi root 3r by 2g. 3r by 2. G,
Right.
सिर्फ G. सिर्फ G होगा.
Moment of inertia is 3 by 2 mr square because ICM is mr square plus m into r square, so 3 by 2 and divided by mgr. So 2 pi root mm gone, rr gone, 3r by 2g. 3r by 2g.
हाँ 2g होगा. R by 2 लेके.
Okay, right. Next is अब हम देखते हैं questions involving a combination of both. So now we'll be doing some miscellaneous questions regarding this. So this is a rod of mass m, length L, which is hinged horizontally about an axis, and it is attached to a vertical spring of a spring constant K. A rod of mass m, length L, and it is initially in the horizontal position. Now we have to find. Now we have to find. We have to find what is the time period of SHM of this rod. In equilibrium, it is given that initially rod is in horizontal position. तो उसका मतलब जो नीचे स्प्रिंग लगी हुई है वो कुछ compressed होगी because it has already balanced the weight and the torque due to weight. Rod is in horizontal position. So जैसा हमने डिस्कस किया था वैसे there will be first condition for equilibrium. There will be first condition for equilibrium, right? There will be one condition for equilibrium and equilibrium में जो भी condition होगी वो हमेशा cancel out हो जाती है. Torque due to mg is balanced by the torque due to spring force, which is already compressed. But हम उन सबको calculate करके we will assume that net torque is 0 because that's what the equilibrium position means. Second step is give a small displacement. अब यहाँ पे एक spring भी है और एक rod भी है, so हम दोनों को आपस में relate कर सकते हैं. We can apply again. Either we can consider this to be in the linear SHM, considering the spring is compressed by x, or we can consider it to be like an angular SHM for the rod which is rotating by an angle theta. So this will start performing SHM like this. So it will be linear as along with angular SHM. You can apply any of the two. Right? बेटा ये समझ में आ रहा है?
Yes, sir.
Yes, sir.
So if you give a small displacement, length is की L है, x और L में क्या relation होगा? X can be written as L theta. Arc length is radius into angle. The spring will have a compressive force of kx and it will apply a torque. हमने दिया था clockwise angular displacement theta and it is having a anti-clockwise torque in opposite direction. So the torque acting on it, there will be a torque due to gravity initially, but that has been already balanced. Restoring torque जो इसके ऊपर लगेगा वो इस force का लगेगा kx का, and perpendicular distance is approximately L only because theta is very small. Right? Theta is very small. So x को हम लिख लेते हैं फिर से L times theta. This becomes L theta into L. So minus of k L square theta. Torque is equal to I alpha. I is equal to ml square by 3. Alpha will become minus 3k by m into theta. Alpha is minus of omega square theta. Omega is root 3k by m. So again we got omega. From omega we can find out the time period. Time period is 2 pi by omega. That's 2 pi root m by 3k. You understood this? Because of the spring. So जहाँ पर भी spring attach होगी, वहाँ से spring का torque we can say k into L square times theta. So for example, suppose another rod case. This is another rod which has two different springs. One is at the midpoint vertically upward K1, another is vertically downwards K2. And in the same case, rod of mass m and length m. What will be its time period? So to find its time period, To find this time period, we have to calculate the torque. This is L by 2 and here it is L. So when you give a small displacement of theta, the restoring torque we can directly write because of the spring only. The gravity torque is 0. So restoring torque will be K1. It is a distance of L by 2. So L by 2 square theta plus K2 into L square times theta. That will become minus of, you understood this? How it is L square directly? जितने भी distance पे spring होगी उसका square कर लेंगे directly. That is a shortcut you can use. Because force में एक आएगा K into X और torque के लिए जब करेंगे तो then we'll multiply with the perpendicular distance also. So this becomes K into L square. Correct? Right. So it will be K1 by 4 plus K2 times L square theta और left hand side में तो वही ML square theta by 3 times alpha tau is equal to I alpha. I hope समझ में आ रहा होगा क्योंकि हम इस चैप्टर कर चुके हैं इसलिए I'm just trying to do it little faster. So ये दोनों का कॉम्बिनेशन हो गया जिसमें स्प्रिंग एक elongate होगी एक compress होगी but as a result both the torque will be in the same direction. Both the torque will be in same direction. This will also apply torque in upward direction. This will also apply force in upward direction. Both the forces are in the same direction and therefore their torque will also be in the same direction. Again, we got alpha and minus theta relation, and that relation, that constant will be omega square. So another some specific type of example like the simple pendulum of infinite length. Simple pendulum of infinite length is not having an infinite time period. It's just a hypothetical version. But जो pendulum oscillate होता है, that is because of gravity. So when we say infinite, it is infinite means with respect to the size of Earth. तो पहले हम किसी large size pendulum के लिए calculate करेंगे. The pendulum which is of the large size means the size is comparable to the size of Earth. This sphere is Earth, and this simple pendulum is of length L. Radius of Earth is R. This is the mean position. Give a small displacement of theta from its mean position or x linear displacement, which is very, very small. This is just for the representation purpose. It has been represented a big. So if this is x, x is that displacement, there will be forces acting towards the center of Earth gravity, that is mg, and another force will be acting towards the string, that is tension. So when this particle is displaced slightly x from its mean position, now there are two forces one component of tension and one component of mg. Both are acting towards its mean position. Here it is theta and on the other side it is phi. So phi and theta. Diagram, there is one force tension because of the string, another force mg because of the gravity, and the force, the angle ऊपर वाला theta and नीचे वाला phi. Theta and phi both will be very, very small because x is very small. It is as compared to the radius of Earth. X is very, very, very small. So if theta is very small, phi is very small, that means हम इन दोनों के भी कंपोनेंट्स को इक्वल कर लेंगे. हाउ? t cos theta कंपोनेंट ऊपर लग रहा है, mg cos phi नीचे लग रहा है. When theta is very, very, very small, cos theta is approximately equal to 1. correct? So T cos theta is equal to mg cos phi. Theta and mg, theta and phi are very, very small. So T is approximately equal to mg. If T is approximately equal to mg, now T sine theta plus and mg sine phi. This is the total restoring force. So restoring force is T sine theta plus mg sine phi. T is equal to mg, so mg is taken common, sine theta plus sine phi. Sine theta will become x by L and sine phi is x by R minus mg 1 upon L plus 1 upon R times x. Again, if we calculate acceleration from here, acceleration will become minus g by L plus g by R times x. Compared to the standard equation, A is equal to minus omega square x. We get omega. Omega is root of g by L plus g by R. Right. So from this omega, we get the time period. Time period of large pendulum. Large means when the size is comparable to the size of Earth radius, g by L plus g by R. If L is infinity, then we will put g by L infinity. ये तो किसी भी बड़े पेंडुलम के लिए अगर एक पेंडुलम जिसकी लेंथ अर्थ की रेडियस के इक्वल है, रेडियस के डबल है, रेडियस का हाफ है, then we'll apply this formula. And when it is infinite length, for infinite length, L is infinity. T is equal to 2 pi divided by g by infinity plus g by R, which is 2 pi root R by g. Infinite length pendulum is also 2 pi root R by g, where R is the radius of Earth. So it will be 84.6 minute again. It is not infinity. Infinite length pendulum, physical pendulum. Simple pendulum, infinite pendulum, and compound pendulum, all that cases we have just done. Yeah. Okay. So this is the time period for pendulum. We did. Now there is next type of questions in which neither the force method works nor the torque method works. More complicated questions. So there is another approach that we can use. टाइम पीरियड कैलकुलेट करने के लिए या तो हम फोर्स कैलकुलेट करें या फिर हम टॉर्क कैलकुलेट करें, बट there are some complicated situation where both the equation become very difficult. So we have third method is energy method. In SHM, the total energy always remains conserved. So total energy in SHM remains conserved. Total energy remains conserved. So from the mean position, give a small displacement and then write all the give a small displacement and write all the energies. Small displacement and write all the energies, and then differentiate energy with respect to time. Differentiate with respect to time. So we'll take one example to prove this. dE by dt, and that will be equal to 0. From here we get the relation between, from this differentiation we get relation between acceleration and displacement. For example, there is a spring attached to a solid sphere. This is a solid sphere of mass m, radius r, and is perfectly rolling on the surface. There is no slipping. Initially, it is in the natural length, mass m, radius r, and this solid sphere is. So, if it is perfectly rolling, means there will be a friction from the ground, and that maintains the no slipping condition. So ये main position है. यहाँ से थोड़ा displace करते हैं. If we give it small displacement, so क्या हो जाएगा? Since it is rolling का मतलब इसके पास एक linear motion भी होगा. It is having a translation as well as rotation. So पहला तो first energy that will come is the spring potential energy, because spring is elongated. This sphere center mass will acquire linear velocity, and along with that it will start rotating above the center से attached है. There will be friction also, but that friction will be like a stick friction, क्योंकि वो उस point पे लग रहा है, इस point पे कोई velocity नहीं है, and that's why it will be. That's why that friction cannot cause any kind of energy loss or heat loss. Write all the energies. The spring energy half kx square. The sphere की translational energy half mv square. The sphere की rotational kinetic energy, that is half I omega square. So this is the total energy. This method will be used only when none of the two method works. Total energy of system after giving a displacement of x. So it become half kx square plus half m into v square. अब चाहे तो हम अभी पुट कर लेते हैं 2/5 mr square is moment of inertia, and since it is moving on pure rolling, there is no slipping condition, the v is equal to r omega omega r. So we replace omega as v by r. Half kx square plus half mv square, ये 2 gone, 1/5 square, ये आ गई total energy, which becomes 7/10, I think. So in this step only, if we solve, it will be little better. Half kx square plus 7/10 mv square, and this is equal to constant. So we got a relation between the x and v. Now we can differentiate on both the sides. Total energy of SHM remains constant throughout the process, so we can differentiate, and that will be equal to 0. So if you differentiate this, dE by dt, यहाँ पे half k x square का differentiation 2x, but because it is in x function, हम t में differentiate कर रहे हैं by using the chain rule. X square का differentiation x में करते हैं, then it is just 2x. But since we differentiated x square with respect to t by using the chain rule, पहले 2x आएगा, फिर हम dx by dt से multiply करें. So by that logic, x square का differentiation आया 2x into dx by dt plus 7/10 m, v square का आएगा 2v into dv by dt, and that should be equal to 0. Now ये 2 से 2 gone, 2 से become 5, k into x, dx by dt को v लिख लेते हैं, plus 7/5 mv, dv by dt is acceleration, vv also gone. 7/5 ma is equal to minus kx A is equal to minus 5k by 7m times x. A is equal to minus omega square x. Omega is root 5k by 7m. Time period is 2 pi by omega, which is 2 pi root 7m by 5k. Correct. So by this method, we can also calculate the time period. That has been the three method: force method, torque method, and third one is by using this energy method. So energy method में थोड़े complicated questions जो बनते हैं advanced level पे, mains level में most of the question you can try. Like this question you could have done very quickly with the torque method if it strikes to you. कैसे? In the same question, if you apply the torque formula, the sphere is having pure rolling. Pure rolling means it is not slipping. ये ground पे जो point है वहां पे slip नहीं हो रहा है और हम इसके about इसका torque consider कर सकते हैं. We can consider the torque about point O, means either the force kx when it is elongated kx and there is a friction Fr. So when it is elongated by x, that means the with respect to the point of contact with ground, this has rotated slightly by an angle theta. P ले लेते हैं इसको. ये radius जो पहले सीधे थी, because of the x displacement, it has rotated by an angle theta. So हम point P पर ले लेते हैं, because point P is also called as instantaneous axis of rotation. क्योंकि इस point के about body is only and only in rotational motion. So जब हम torque calculate करेंगे, restoring torque about point P, it will be force which is kx into perpendicular distance r, opposite direction में, so minus kx force because of the spring elongation. Spring is elongated by x, so there is a force kx in opposite direction. Friction opposes, friction causes the body to accelerate in the forward direction. लेकिन जब हम torque calculate करते हैं about point O, so हमें moment of inertia भी उसी point के about चाहिए, is equal to minus k. X will become r theta. Sphere का center के about moment of inertia 2 by 5 mr square. उसमें हम mr square add कर दें. So moment of inertia about point P जो मिलेगा हमें, that is 7 by 5 mr square. Moment of inertia about this point is 7 by 5 mr square. So 7 by 5 mr square alpha is equal to minus kr square theta. Alpha will become minus 5k by 7m times theta. That will be minus of omega square theta. You can see that omega is again the same, root 5k by 7m. So you can choose any method, whichever method suits you, whichever method strikes you. It's not that energy method is the only option. Again, you get the same value of omega, same value of omega. So many questions have information given in some other form. You have to calculate, you have to find the value of omega. From omega, we get time period. So these are the equation of SHM, calculation involving time period, equation, energy. Most of the all possible varieties we have done. Some questions now we want to do from this part, and then only the damping part is left. Damping in SHM. And recent years in JEE especially, the questions from damping part has been asked mainly because damping is usually we don't do in much detail in the school level or normally. Yeah. Right. So the question says a simple pendulum from the roof of the elevator. A simple pendulum from the roof of elevator has a time period T1 when elevator moves up with acceleration A. When it moves up with acceleration A, the time period of this pendulum is T1. When it goes down with acceleration A, its time period is T2. Now the question says when the elevator moves down with acceleration A, its time period. Wait. It says that time period of a pendulum attached with the elevator is T when it is T1 when it is not moving anywhere. When it is going up, then it is T2, and when elevator goes down, it is T3. When elevator is not moving, in that case, it is T. When elevator is moving up, then it is T2, and when elevator is moving down, then the time period is T3. You have to find relation between T and T1 and T1, T2, and T3. So T1 is root T2, T3. This is the first option. T1 is root of T2 square plus T3 square, and T1 is root 2 T2 T3 divided by T2 square plus T3 square root. So you have, and see, D is none of these.
C.
Abda?
C.
C.
Yes, sir.
Okay. पहले सॉल्व किया आपने शायद.
नहीं मतलब अभी जब आप लिख रहे थे तभी मैंने सोचा था यही क्वेश्चन होगा.
अच्छा. 2 pi root L by G. T1 is 2 pi root L by G plus A. T2 and T3 is 2 pi root L by G minus A. So what we can do here is 1 upon T2 square, or other 2 pi by T2 whole square will become G plus A by L, and similarly 2 pi by T3 square will be equal to G minus A by L. Add these two equations. 4 pi square plus T2 square is 4 pi plus 4 pi square by T3 square will be equal to G plus A, G minus A, that becomes 2G by L. और यहाँ से आ जाएगा 2 pi by T1 is root G by L. G by L will become 4 pi square by T1 square. Into 2. So 2 by T1 square is 1 upon T2 square plus 1 upon T3 square. Take LCM and root, so it will be C option. Yeah, so that was simple one. Next is Next is again I'm taking some standard cases which have been asked in the exam. Next is there are three springs. At an angle of 120, 120 और बीच में एक छोटा सा मास लगा हुआ है. Find the time period of SHM of this mass, small particle of mass m connected to the three springs as shown.
टू पाई रूट 3k/2 नहीं
Find the time period of SHM of particle of mass m. क्या करेंगे इसमें? We have to give small displacement x. We'll give a small displacement x from its mean position. So let's say downward direction. It's given as x. ऊपर वाली स्प्रिंग तो कंप्रेस हो गई. नीचे वाली स्प्रिंग जो वर्टिकल स्प्रिंग थी that gets compressed. That get compressed by distance x, and as a result these two springs also have some elongation. This is y. जो vertical spring थी उसमें x का elongation हुआ, which means that vertical length is x, और जो side वाली दोनों springs हैं इनमें y का. This is y and y. Angle 120 था, half करोगे 60 आ जाएगा. Y is base, x is hypotenuse, is equal to cos 60. So y की value आ गई x time cos 60. In this question is 60. Otherwise, the general equation will be cos theta. Cos 60 is 1 by 2, so y will be x by 2. So the forces that has been now applied on this, एक इसके spring के नीचे वाले spring की वजह से आ जाएगा force kx. Because of these two sideways spring, elongation is y, so force will be ky along the length of this. It is compressed by x, so spring has a force of kx, the vertical spring. Those two sideways spring, the inclined spring has elongation of y. It has force of ky and angle is 60, 60. फिर दोनों का रिजॉल्व करोगे तो ky cos 60. It is ky cos 60 from here and from the other side also. So दोनों तरफ से जो force लग रहे थे, this is kx. इधर ky का resultant, दूसरा इधर ky का resultant. So plus 2 times ky cos 60. The net force is equal to kx plus 2 ky cos 60. x, अब y की वैल्यू है x by 2 और cos 60 की वैल्यू भी 1 by 2. So this becomes kx plus kx by 2. So f will become 3kx by 2 और ये अपोजिट है क्योंकि हमने नीचे की तरफ डिस्प्लेस किया था और फोर्स ऊपर की तरफ लग रहा है. So net force will become minus of 3kx by 2. Force से acceleration और acceleration से we can calculate omega. A is equal to minus omega square x. So ये कोई नया कॉन्सेप्ट नहीं था, बट एक नई सिचुएशन है जिसमें हमें वर्टिकल अगर बहुत सारे स्प्रिंग्स लगी होंगी तो हमें उस डायरेक्शन में फोर्स का कंपोनेंट चाहिए, द कंपोनेंट व्हिच इज in the direction of mean position where we give the displacement. Compare with the equation. A is minus omega square x. Omega is root of 3k by 2m, and then we can find the time period 2 pi minutes. Right. So these are all the cases in which we find we will find the position. We'll find the SHM time period. Which energy wale questions kiye humne. Now we'll do the damping in SHM. So why does the damping occur? All these equations that we have written is hypothetical because we have assumed them in vacuum. In vacuum, there is no medium, there is no drag, there is no loss of energy. Jitni bhi energy humne de di, the total energy will remain constant, which is a hypothetical case. It is not possible. Only and only in vacuum it is possible that it does not have any type of energy loss. But practically it will always be some medium, maybe air, maybe water or any other material. But in vacuum it's not present, the normal pendulum that we use in the laboratory. So because of the medium, there is always a drag. If it is a liquid, then that's called viscosity. Otherwise, in the air, it is called air drag. So when this is given a displacement of x, it has acquired a velocity of v. Force kx and damping force vv. So the force acting on it, force acting on the block F is equal to minus kx minus vv. Bv here is that drag force or damping force or air resistance. Minus Bv is called F is equal to minus Bv is called drag force or damping force, and B is called damping constant. B is called drag constant. So if it is a liquid, then it will become B will become 6 pi eta RV. Right. So हम acceleration निकालते हैं और फिर we'll make the equation that acceleration equation is force upon mass. The differential equation will become minus k by m times x minus b by m times velocity. Acceleration is double differentiation. Velocity is dx by dt plus k by m. So this is second order differential equation, जिसको हम mathematically solve कर लेते हैं, but not in our syllabus. So this is the standard equation of damping. When the medium is present, there will be some resistive force applied by the medium, and due to which there is always some energy loss. So damping का मतलब क्या है? Due to this air resistance or air drag, the energy will be lost, amplitude will be lost gradually, and finally the SHM will stop. The body will stop oscillating because of its energy gradually lost due to the damping or due to this air resistance. So इस equation का जो solution है that we have to use directly, we cannot solve this equation. The solution of this equation is, on solving this equation कैसे solve करते हैं उसके लिए कुछ standard solution है जिसको अब रख के put करके देखते हैं. It is a into e raised to power minus bt by 2m sine of omega t plus phi. Omega d मैंने लिख लिया because it is for the damped frequency, or omega dash, whatever. Amplitude, now you can see that amplitude is not constant, it is changing with time. It is a function of time now. This is the amplitude at any time t. It starts with a only. When t is equal to 0, amplitude is a, but with time omega dash is the damping frequency. Natural oscillation frequency was root k by m minus b square by 4m square. Amplitude after time t. So equation, when we plot this on the graph, it will be amplitude will be exponentially decaying. So which means the amplitude of this function will lie between this, इसको हम बोलते हैं envelope of the graph. This exponential जो function that's called envelope, which means if we join the maximum displacement points, it will be like a exponential form. Amplitude gradually reduces, and that causes energy to loss, but it will take infinite time to completely die out. But practically after 20 oscillation or so, we will not be able to see that oscillation, since this amplitude become displacement amplitude is very small. Right. So amplitude जब हमें t टाइम के बाद निकालना हो, तो वैसे तो ये फॉर्मूला है, बट हम इसको थोड़ा सा tricky method यूज कर सकते हैं. How? We can compare this with the nucleus disintegration and radioactivity. Amplitude at time t, it is, let's say 80. We represent this as a sub t, a into e raised to power minus bt by 2. If you remember the nucleus decay, the formula for number of nuclei present at time t. Initial number of nuclei m naught. So number of nuclei that is remained after time t, n is equal to n naught e raised to power minus lambda t. If you compare, like n naught was the initial nuclei, number of nuclei, here it is a. Lambda was the decay constant, here lambda becomes p by 2m. Lambda will be b by 2m, that is equivalent decay constant. So all those formulas that we had for radioactive decay, we can use here, like half-life time, the number of nucleus remained after n half-lives. All those formulas we can apply. Average half-life, mean life, half-life time period, and the time taken to decay from one amplitude to another amplitude. All of those can be used with the help of this formula of radioactive decay. Just say, for example, time taken for amplitude to become half. Time taken for amplitude to become half. Half life का formula क्या होता था? Time taken to reduce by half. T half formula था in this ln2 by lambda. Here also it becomes ln2 divided by b by 2m. The time in which amplitude reduces to half of its initial value. Amplitude after n half lives. Amplitude after n half lives. It will be a into half to the power n. amplitude after and half life is a into half to the power n, right? Okay, so energy of SHM was half Ka square or half m omega square a square. Since the amplitude is decaying with time, amplitude is a e raised to power minus bt by 2m square. The energy will also reduce half Ka square e to the power minus bt upon n. Initial energy is E naught, E is equal to E naught, e to the power minus bt by E naught is the initial energy, half Ka square lambda is b by m. So यहाँ पर जो damping factor है, that is e raised to power minus b by m. So there's a difference of 2. In the amplitude it was b by 2m, in the energy it is b by m because we did the square, so that 2 get cancelled. Right? Okay. Next is because of the damping, the energy is lost. But suppose if you have to maintain the frequency, maintain the amplitude to a certain value, then we have to apply a gradual periodic force. Done, right? So ये हो गया energy of force और सच में क्या होता है? In spite of having the damping, क्योंकि medium तो हमेशा होगा, हमें अगर उसको maintain रखना है to a constant amplitude, then we have to apply a gradual periodic force. वो f naught sin omega t हो सकता है, f naught cos omega t हो सकता है. This external periodic force is required to maintain the amplitude at a constant value, and quite obviously ये जो फोर्स लग रहा है, इस फोर्स का एम्पलीट्यूड ही डिसाइड करेगा कितना नया एम्पलीट्यूड होने वाला है. एग्जांपल, अ चाइल्ड ऑन द स्विंग इन पार्क, if you start pushing from behind, now you are deciding what is going to be the amplitude, not the length of the pendulum. So इसमें ये वाला part जो है, this is called the natural oscillation or natural frequency, and the second word is force. Natural oscillation is omega naught, and this is with the frequency of omega. So अभी natural oscillation तो खत्म हो गया, जो भी है वो force की वजह से, that is the force oscillation. So amplitude will remain a new amplitude, whatever is that will be constant, into cos of omega t plus phi, because omega is the driving frequency of the force, जिस force से हम system को drive कर रहे हैं. The natural length, natural mass doesn't matter anymore. It is the external force. If you start pushing early, quick, then it will be having less time period. But amplitude of SHM in force is force SHM F naught divided by m omega square minus omega naught square plus omega square b square whole raised to power 1 by 2. Omega is the frequency of force, omega naught is natural frequency, and F naught is the force amplitude. So this is a formula for amplitude of periodic force SHM. right? So in this formula, there are two cases when omega is very, very large as compared to omega naught. जब omega बहुत बड़ा होगा तो भी ये पहला टर्म में omega naught cancel out हो जाएगा. हमें omega naught को हम neglect कर देंगे. When omega is very, very small, तो omega को neglect कर देंगे. So when frequency is very small or very large as compared to omega, this term won't be zero. There will be one term greater than the other. So it will have some positive value because it is a whole square. But when omega is equal to omega naught, if the frequency of the force is matching with the natural frequency of oscillation, if omega is omega naught, then amplitude is maximum, and this is called SHM. This is called the resonance. So amplitude is maximized, and that maximum amplitude will become f naught divided by omega naught b, because this will be equal, so they will get cancelled out. Max amplitude is f naught. अगर ये इसमें damping नहीं है, it is a natural frequency, natural oscillation only. Like if there is no damping, then it will be infinite. It will have infinite amplitude, which is again practically not possible, that there is no medium. Right, so amplitude will be maximized at this particular frequency, which is called as resonant frequency or natural frequency. Right, so okay, I think it's done. Next class we will start waves, so you have to solve the questions from the previous year questions, and wave is related with SHM, so you can quickly revise. Wave and SHM is very, very, very important. At least 3 to 4 questions you can expect. Wave is again very closely related with the wave optics. So only if wave is clear, wave optics will be clear. Right? Okay, we'll continue tomorrow from here. Thank you.
Thank you.
Soumya.
Yes, sir.
So it is a quick revision of the concepts, and now you have to solve question and doubts. For doubts, weekend will give time for in which we will discuss the time, all the doubts. Right. So that's how the quick revision of the crash course works.
Okay, sir.
Rushil,
Yes, sir.
right. I think you were also supposed to ask doubt. When your father told that mostly it is required for doubts. So weekend I'll give the time. So in that combined group class, we will have the doubt session for. So before the class, send all the doubts from the concerned topic first, and
Okay.
after that, you can ask from any doubt, any topic. Okay then. Thank you. Bye-bye.
Thank you, sir.
Thank you, sir.